Hi, Chris Kuzmal here. We now are in a position to modify the successor method so that it actually works. And if you look carefully, you can see that we have 10 passes and one fail. I've already fixed it offline. Let's go through what I did. Uh, and here we see on line 46 the old successor method, which I've renamed to old successor. And what it did was the same thing as a linked list does, which is to say it starts with the return value will be kind of by default the node itself. But what we're going to do is we're going to get the left child, because the left we treat the left child like the next in a linked list. And in a linked list, all we do is we just get the left child and we're done. Um, Except that we modified this to be a while loop, which sort of was just weird, because what it did was that meant it went all the way down the left branch, which sort of makes sense because the initial element of a linked list, initial element of a binary search tree will be all the way down the left side. So this was an implementation, in other words, of the minimum function, not the successor function. We see the similarity up here of the two. So this was just a placeholder. Uh, the successor method is actually in a lot of ways similar, though. We start off making our return value to be the original node, but now we check to see whether or not the right child is not null. And it helps to go back and take a look at the graphical explanation of how we do the successor operation in a binary search tree. But if the right child of a node isn't null, then the successor of that node is the minimum of the subtree to the right. And that's exactly what we do here on line 56. We invoke minimum, which we've just defined and we've already tested and already works. So the minimum of the right child is your successor if you have a right child. But if you don't, you've got to check the parent and say, okay, if the parent, if you're the right child of a parent, which that's what this equality is, and the parent isn't null. If that's the case, then we need to set the ret val to the parent and find out what the parent of that parent is, and then find out whether or not that guy is the right child. And as long as you're continuing to have nodes that are right children, we need to keep going up the tree. When we finally get up to the point where we found someone who's not a right child, and assuming we haven't found null, which is going to actually really be an error case, then we're going to return that node, because that node is the successor, because that's heading back to the right, and that's in some sense. So that's it. That's how it works. We probably need some more test cases, but that is the successor method as implemented in Java for binary search trees.